from transformations, and then also we're going to solve a couple problems algebraically here. So I'm going to start out by talking a little bit about transformations, and this is going to relate back to what we talked about in chapters 2 when we looked at absolute value, and then also in chapter 4 when we looked at quadratics. So now we're dealing with the parent function of an x cubed. So y equals x cubed, that's called your parent function. And then you can apply transformations to it by putting it into this vertex form. The only difference is now we're dealing with this cube instead of a squared or instead of an absolute value like we talked about back in section 2, chapter 2. And I didn't want to do that, but that's just what happened. Sorry about that. So just to review, anytime you have a negative a, that's going to be a flip over the x. Anytime we have a that's greater than 1, that's going to be a stretch. Anytime we have an a that's between 0 and 1, that's going to be a shrink or compress. And then lastly, h is going to move us left and right. And then k is going to move us up and down. So there's going to be all of our transformations, and then how I can represent them in that function is going to be using this general vertex form that I have over here. So we'll take a look then at number 1, and we're just going to kind of piece together how to write this equation. So I'm going to write my equation over here. I'll start with a y equals. So first it says a vertical stretch by a factor of 2. The stretch or compress flip is all going to be my a value. So that means that my a value is going to be 2. Next, it says a vertical translation of 4 units up. So up and down, that's going to be my k value. And then 3 units left, that's going to be my h value. So I'm going to open up parentheses to represent that h value. I'm going to have x. Now, anytime I'm moving left, I have to kind of think backwards. Moving left with these transformations in my function is going to be an x plus 3. That's going to be 3 units left. Then I'm dealing with a cube function, and then 4 units up is going to be a plus 4. So there would be my representation of number 1. So number 1, I'd have y equals 2 times x plus 3 cubed plus 4 is going to be my result. So you're going to notice that this is going to be exactly the same as when we did quadratics. The only difference is you have an x cubed instead of an x squared. So it's going to be all very similar to that. Next, we'll do number 2. So we'll go y equals. We've got a reflection across the x-axis. That means my a is going to be negative. Vertical translation 1 unit down, and a horizontal translation 5 units right. There is no stretch or compress, so that's just going to be a 1. So I'm just going to put a negative out in front. 5 units right is going to be x minus 5 cubed. And then 1 down is going to be a minus 1. So there would be my function for number 2. So moving 5 right, 1 down, and then the negative out in front is going to mean that I flipped over the x-axis. So I know Mason asked that question, but just kind of looking at all of you, if you can just kind of give me a head nod, is that kind of making sense, kind of reminding you from what we did back in chapter 4 a little bit? So you're going to see very similar. Another thing that's on our schedule, if you go into our schedule, if you hit the green Desmos, that'll open up graphing technology. And then you can always check your answers on there. So if you type in your function that you found, you should be able to start to see how that function transforms. So you can use that Desmos. If you just click on that icon there, it'll open up your Desmos, and you can kind of play around with that as well. Secondly, then, we just wanted to talk a little bit about solving algebraically. So finding the zeros. So finding a zero of a function, first thing that we have to do is we have to set it equal to 0. So we're going to replace y with 0, and then we're going to solve it out algebraically. So really, I'm just going to use my basic algebra skills, just working backwards through the order of operations to start to solve this out. So first thing I would do is I would get the 8 moved over by subtracting 8. So I'd have negative 8 is equal to negative 27 x minus 2 cubed. Next thing is I got this 27 multiplying that x minus 2. Now that looks like possibly doing a distributive property, but you got to be careful. You'd have to cube whatever this is first because of order of operations. So we're not going to do that. We're going to divide both sides by negative 27 because it is multiplying. And I'm going to move over here because I got some more space. So negative divided by negative is going to make that positive. So we have 8/27 is going to equal x minus 2 cubed. Now I got to undo this cube. So we're going to have to use a hint back in chapter 4 when we had to undo a square. We took the square root. Now that we're dealing with cubes, to undo a cube, we are going to use a cube root. So a cube root is a little 3. It's called the index of your radical. A little 3, and then we are going to cube root that. On your calculator, where you can find your cube root is if you hit math, it's going to be the fourth one down. So there's your cube root, and then we could put in, oops, I think I hit something wrong there. It's going to be the fourth one down, which is right there. That's not what I wanted. Just hit 4. There we go. Then I'm going to hit 8 divided by 27, and we get our answer. So 0.66 repeating, that's going to be 2/3. So we're going to get 2/3 equals x minus 2. And then lastly, we'll add 2 over, so we're going to get 2 and 2/3 is equal to x. So we are just going to use our algebra skills, and once we get to that point where we have to undo that cube, we can cube root. And like I said, I'll have this video posted, so if you forget where that is, you can scroll through, find to see that key sequence again on my calculator. But that brings us to 10:03. So I will continue to work on any questions that you have if you want to stick around, but if you want to, you can go off on your own. If you do, you can also go into Desmos and you could graph this out and then just check where is that x-intercept, where is it crossing the x-axis, and then you could start to see if your answer, 2 and 2/3, would be correct. So Desmos is a good tool that you can start to use to graph out these functions and kind of get a good picture of what's going on. So I will stick around, but if you want to break off to work on your own, you can do that. If you have any things that you need from me, you can throw it up in the chat. I'll turn on GoGuardian so that if you want to discuss something with me privately on GoGuardian, I can get a hold of you that way. But if you are ready to start working on your own, you can go ahead and break off on your own. I will have the Google Meet open until 10:25 for any extra help that you need.